In this video, our learning target will be to graph quadratic functions from intercept form. Now, intercept form is, I think, easier than standard form, but you have to be able to recognize it. The main thing you're going to see when you see intercept form is two sets of binomials where you have x in them. Now, there's still a coefficient a out in front, and just as before, if a is bigger than 0, you know the graph is going to open upwards, and if a is less than 0, you know it's going to open downwards. So that's kind of a nice thing to check out right away. Now, the other important features from intercept form are these values p and q. These are the values that are being subtracted from x in parentheses. Now, you'll kind of remember from the vertex form where you had x minus h. The h value was what was being subtracted from x in that vertex form, and we said take the opposite of that number, and it's going to be the same thing when we look at p and q. So the x-intercepts occur at p and q, and those are going to be the opposite of the number that you see in parentheses with x. The axis of symmetry is halfway between those intercepts at p0 and q0, and I'm going to actually do even better than that. I'm going to give you a formula that you can use to find the axis of symmetry. It's going to always be of the formula x equals p plus q over 2. That's just the average of the two intercepts. That will always be the axis of symmetry, and also this is how you can find the x coordinate of the vertex. So that will definitely come in handy when we do some problems. So let's take a look at the first one here together. In this example, my a value is -1, so I know it's going to open down, and it's the same width as y equals x squared. Now, the p value and the q value are going to be the opposite of the numbers I see in parentheses with x. So if I see x plus 2, then I know my p value is going to be -2. And if I see x minus 4, well then that means my q value is going to be +4. These are going to be the coordinates of the x-intercepts at -2, 0, and at +4, 0. So that's where the parabola will actually cross the x-axis. So let's plot those points at -2, 0, and then at +1, 2, 3, 4, 0 is going to be another coordinate. Now, in this case, you know the parabola is symmetrical, so the axis of symmetry is halfway in between those 2 points, and you can see there's 1, 2, 3, 4, 5, there's 6 bases, so if you went 3 over, we'd land right here. Now, sometimes it's not quite as obvious where the axis of symmetry is, like it is here. We can just dash in our axis of symmetry. Let's pretend for a moment that we didn't know it and that we need to rely on this formula. If I did, I'd just do x equals p plus q. In this case, it'd be -2 plus 4, and then I divide that by 2. Using the formula, that would give me 2 over 2, which is 1. And you'll notice that is exactly where the axis of symmetry is. It's x equals 1. So if you do get a tough one that you can't really see exactly where that axis of symmetry is, you can always do that. The nice thing now is all I have to do is plug in the x coordinate of the vertex 1 to find the y coordinate of the vertex. So since I know x is 1 is my x coordinate of the vertex, if I plug that into the formula, it's going to turn into the following. I'm going to get y equals negative, and then it's 1 plus 2 in parentheses, and then if I replace the x with a 1, it's going to be 1 minus 4 in the second set. So I get y equals negative, 1 plus 2 is 3, and then 1 minus 4 is -3. Ultimately, this is -3 times -3, that's y equals +9. That tells me the vertex is at 1, 9. So let's plot that, 1, 9. So I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. That's way up here. Now I have enough coordinates to plot here. I'm just going to try to draw a smooth curve, a parabola that goes right through there and through there. So that's how you graph from intercept form. Let's do another example. Okay, so in this example, my a value is not written there, so I assume it's a 1. That means it's going to open upwards, and it's the same width as y equals x squared. And for my p-value, I look inside the parentheses with x, and I notice I have a negative 3. So that tells me I'm going to use a positive 3 for x. And my q-value, since I see a negative 1, I know I'm going to use a positive 1. So I'm going to just jump right to my graph and plot a coordinate at 3 on the x-axis and at 1 on the x-axis. And once again, this is pretty easy to see. Right in between 1 and 3, the average of that is 2. So I can kind of dash in an axis of symmetry here. And I know that axis symmetry is x equals 2. And if I plug that in to get the y value, the vertex, I have to do 2 minus 3 in the first parentheses. And then we got to do 2 minus 1. So 2 minus 1 in the second. So 2 minus 3 is negative 1. 2 minus 1 is positive 1. And 1 times negative 1 is negative 1. So my vertex is positive 1, comma, negative 1. Or excuse me, I plugged in 2, didn't I? That's a mistake. So that was a 2. We plugged in for x and got negative 1. So 2, negative 1 is right here. And so if I make my smooth curve, whoosh, looks just like that. A little bad aim on that one, but I have an excuse. I'm using an iPad. I'd like you guys to give this one a try and see how well you do. Good luck, and thanks for watching.